In this video on atomic structure, we'll take a look at half-lives. We've mentioned before that radioactive decay is a random process, but we can predict roughly how many atoms will decay in a given amount of time, and that's what links us to the term half-life. The definition: the half-life of a radioactive isotope is the time it takes for the number of nuclei of the isotope in a sample to halve. Although there's a second definition, and that is the time it takes for the count rate or activity from a sample containing the isotope to fall to half its initial value. Either way, it's the time that it takes for half of the radioactive nuclei to decay. I've underlined the word isotope here just because it's one of those words that people do get confused about, and there's a separate video on this topic that's available for you to watch. So let's now take a look at one of the graphs that you'll be expected to be able to analyse. Along the y-axis, we've got the counts per minute. So just here, it tells us that there's 80 bits of radiation, so alpha, beta or gamma, but there's 80 bits released every single second from our radioactive sample. And then we know the time starts at the beginning just here at time 0 and goes on for about 10 days. So to find the half-life, we need to remember our definition. It's the time it takes for the radioactive nuclei to halve in value. So if it starts at 80, we need to half that value, find 40, go across, and then down. So we'd use a pencil and a ruler to do this. So the half-life for this would be 2 days. But then it will carry on halving. So another 2 days later, it will halve again. And we can see that because at 20, so this time we halve 40 down to 20, go across, and it takes 4 days. So if it took 2 days to halve to 40, it takes another 2 days to halve to 20. And then again, the third half-life, halve 20 down to 10, go across, and it's then 6 days. So for every 2 days that occurs, the radioactive sample will be half as radioactive as it was before. So for higher tier students, you need to be aware of some of the maths involved. So after 2 half-lives, there will be a quarter of the radioactive atoms remaining. So after 1 half-life, there's of course a half. Because it halves again, so 2 halves, that's then after 2 half-lives, that will therefore be a quarter. And therefore, the third half-life, well, it's halved 3 times, so it's a half, a quarter, then an eighth. So after 3 half-lives, there will be an eighth of the radioactive atoms remaining. So just to check that, we started at 80, and then after 3 half-lives, there's 10. So yes, there's an eighth remaining. And this will carry on. So 4th half-lives will be a 16th, etc.